Good morning, students. So, today we are going to discuss the last portion of our second unit. In this portion, we will study about physical and chemical changes and then types of elements. We will be studying about pure substances. Pure substances are elements and compounds, and then there are three types of elements that also we will be studying, and we will compare compounds with mixture. Okay, now let us start with physical and chemical changes. So first of all, we will be discussing what is a physical change. So the interconversion of state is a physical change because these changes occur without a change in composition and no change in the chemical nature. So what is the physical change? When there is no change in chemical nature. Chemical properties do not change. If chemical properties do not change, then it is just called a physical change. So in this, what happens? There is just interconversion of states. Means solid may change to liquid, liquid may change to gas, gas may change to solid, or vice versa. Okay. For example, ice, water and water vapors, if we see them, then their physical properties are different, but chemical properties, if we will see, then they will be similar. So it means these are three forms. So if we see the conversion of ice into water or water into water vapors, then we will say that it is a physical change. Now let us see the picture. In this picture, we have taken butter and which we are heating. After heating, it changes to liquid state. So this type of change is called physical change. Okay, now come to chemical change. Now in chemical change, there will be change in the chemical properties. Okay, there will be change in the chemical properties and a new substance will be formed. When two or more things will combine and they will form a new substance, then it will be termed as chemical change. Okay, now chemical change is also called as chemical reaction. Okay, for example, burning of paper is a chemical reaction or chemical change. So why burning of paper is a chemical change? Because when paper burns, it forms ash, and ash means something new substance has formed. Okay, so in this diagram you can see this shows the melting of ice, means it is a physical change. This shows burning of wood, so it is a chemical change. Now one example which you have to remember is, sometimes we are asked which process occurs in burning of a candle. So physical as well as chemical changes both occur in burning of candle. Now see in this diagram what you can see. Here you can see liquid state of wax. So solid wax has converted into liquid state, so it means it is physical change. Now suppose this was the length of our candle and here we were burning it. Then with the passage of time, its size will keep on decreasing and whole of the wax will finish after some time. So wax has changed into light, heat. Okay, so it means that this is a chemical change. So when wax changes into heat and light, then it means it is a chemical change. So both the processes occur in this example. Now let us discuss the types of pure substances. There are two types of pure substances. One is elements and other is compounds. So let us first discuss elements. So Robert Boyle was the first scientist who gave this term element. At what time he gave? In year 1661. Then another chemist, Antoine Laurent Lavoisier, he was a French chemist. He gave the definition of element. Okay, what is the definition which is given by him? It is, an element is a basic form of matter that cannot be broken down into simpler substances by chemical reactions. Now here you can see some pics of elements. These are different elements. So element includes three types of substances. metals, non-metals and metalloids. So here we have just taken, these are all metals I suppose. Okay. So now let us discuss the types of elements. So elements can be divided into three categories: metals, non-metals and metalloids. So first of all, what are metals? If a substance shows these properties, then it will be termed as metal. Okay. Now first is they have a luster. Luster means they shine a lot. Okay. They will be having their own shine. They have silvery gray or golden yellow color. Okay. And they are very good conductor of heat and electricity. They show the property of ductility and malleability. Ductility means if a substance can be drawn into wires, then this property is called ductility. And if we can draw thin sheets after hammering, then it is called malleability. So metals have both the properties, ductility as well as malleability, and they are sonorous. Sonorous means they produce sound when hit. Okay. So for example, gold, silver, copper, iron, sodium, potassium, etc. There are so many metals. One thing which you have to remember is mercury is also a metal and it is liquid. It is having liquid state. Okay. Now see here, this is gold, this is silver and this is bronze. Okay. So these are also, what do we say, they show these all properties. Now let us come to non-metals. Non-metals will be those which will show these properties. Now what are the properties? They exist in variety of colors and they are poor conductor of heat and electricity. Okay. They are non-lustrous means they do not have any particular shine, they do not produce sound, and they cannot be drawn into wires or in thin sheets. Okay. For example, all the gases, whichever gases we see, they are non-metals. Then iodine, carbon, bromine, chlorine, etc. These are all non-metals. Now here some pics we have shown. In this pic, the balloons are filled with different gases. So these all gases are non-metals. Okay. Now here we have taken powdered form of few substances, and these substances are also non-metals. Okay. Now let us come to metalloids. Third category is metalloids. Now these will be those substances which have properties between metals and non-metals. Okay. Few properties will be like metals and few will be like non-metals. Now here we have shown few metalloids: boron, silicon, germanium, arsenic, antimony and tellurium. These are typical metalloids, so you have to remember these. Okay. Now it comes to second type of pure substances. Second type of pure substances are compounds. Okay. So what is a compound? A compound is a substance which composed of two or more elements chemically combined with one another in a fixed proportion. Now let us understand formation of compound with the help of an activity. Now let us divide the class into two groups, and to both the groups we will be giving 5 gram of iron fillings. Iron fillings means iron powder. 3 gram of sulphur powder. Sulphur powder is yellow in color, and they will be given both the things in a china dish. Then group 1 will be told to just mix and crush these two, means crush the two substances properly so that a proper mixture is obtained. To second group we will say that you crush the two things and then you start heating it till it becomes red hot. Red hot means till it becomes red. Okay, you have to heat to that much temperature that it becomes red. Okay, then what we will see, then with the first group and with the second group, to both the groups we will check these things. First we will check for magnetism. Magnetism means we will bring a magnet near the results obtained by both the groups, and then we will see whether they are attracted towards magnet or no. So what is going to happen? In group 1 we have obtained just a mixture, means in group 1 we have obtained Fe plus S, whereas in second we have obtained a compound. That compound has the formula FeS, iron sulphide, and group 1 has obtained just Fe plus S. So group 1 will show the properties of Fe. Fe is iron, so iron filings will be attracted towards magnet. But in the second group there is FeS, it will not be attracted toward magnet. Okay. Then second thing, compare the texture and color. So here in the first group they are just mixed, so there will be no more change in the color. But in case of FeS, color will be totally different. Okay. Now what we are going to do, we will be adding carbon disulphide, this is a liquid, to one part of the material obtained. Means what we will do, we will divide in two portions. Whatever is with group 1 and group 2 we will divide with into two portions. In first portion, in both the cases, we will add carbon disulphide, CS2. Carbon disulphide is CS2. This is a liquid. Then we will find no change. Okay. Then we will add dilute sulfuric acid to both the cases, and what will happen when we will add dilute sulfuric acid, then in the group 1 there will be formation of hydrogen gas. Hydrogen gas will be formed in first case, and in second case there will be formation of H2S gas. Okay. So this is the result which we will get. Now see, in the pics you can see this is iron, this is sulphur, and here we are heating it, okay, till it becomes red hot. Okay. Now let us again revise what we will be getting. See, sulphur was like this was sulphur, this was iron, and this is iron sulphide. Okay. Now let us revise what we will be getting after putting sulfuric acid in both the cases. In first group we will be getting hydrogen gas, because there is Fe plus S. When H2SO4 will be added, Fe will combine, it will form FeSO4 and H2 gas will be given out. In second group there will be formation of hydrogen sulphide. Okay. So its smell is like rotten eggs. Okay. So it means the product obtained by the two groups show different chemical properties. Okay. Means different chemical properties means second group gave different properties, but first group gave the same properties. If iron and sulphur are also placed differently, they are not mixed, then also they will show, this Fe will show magnetism, and after mixing with sulphur also it is showing magnetism. So it means group 1 has same chemical properties, whereas group 2 has obtained a substance which has different chemical properties. It means group 2 obtained a compound, whereas group 1 obtained just a mixture. Okay. Now this whole thing can be understood by this. Okay. Now see, matter is either solid, liquid or gas, which can be divided in two categories: pure substances and mixtures. Pure substances are further divided into elements and compounds. What are elements? This we discussed. This is the definition of elements. In compounds we discussed. This is the definition of compounds. Similarly, mixtures we have already discussed in the beginning of this chapter, that homogeneous mixtures and heterogeneous mixture. Homogeneous means having uniform composition. Heterogeneous means having a non-uniform composition. With the help of examples we can clearly see the difference. Okay. So this was all about this chapter, and now on the basis of this you have to solve these home assignments. Thank you.